So just quickly recap solving quadratics. You want to make sure you are factoring out the GCF first, always, no matter what method you're going to be using. And remember, the quadratic formula is here. Remember how to factor. Some things are factored easily. Remember, this one we did was kind of a special case. You don't want to divide by 2x here. You want to make sure that you pull the 2x over, set it equal to 0, and then factor out the 2x so that you get both, factors and then both solutions of x. So that's 0 and positive a half. All right, and then we talked about the rest of these. The answers are at the bottom. We talked about completing the square. So completing the square for solving a quadratic sometimes is easier than the quadratic formula. So if you can factor something, go ahead and factor it. That's the easiest, right? If it's easily factorable, then go ahead and factor it. But when we look at this example, right, if we try to think what multiplies to be -7 and adds to be +4, there's nothing. So it's not factorable. So our choice here is either to do the quadratic formula or to check to see if we can complete the square. We just had the question come up about when can you complete the square. So here's the rules for when it's possible to complete the square. You're going to look at these first two terms. The first term needs to be x squared, not 2x squared, not 3x squared, not anything else, but just x squared. And the middle term has to be an even coefficient, right? Because think about the process. When we complete the square, we take half of that middle term, right? If it's an odd number, you don't want to take half and then you're working with fraction. That's not going to be helpful, right? So the middle term has to be even, and the first term needs to be x squared. If that's the case, then you can complete the square. We did this one in class the other day, so let me do B, right? So the first thing you want to do is keep those first two terms that we just talked about on the left and the numbers on the right, leaving a blank there. This one already had the -9 on the right. Over here, remember, we had to move it over. Okay, there's a blank. I like to write my blank. You don't have to write the blank, but there it is. Now, you're basically taking, some people like to think of it as, you know, A, B, and C, right? You're basically taking B over 2, half of the middle term, and squaring it. And that's what goes right here in this blank and this blank. So half of the middle term and then squaring it. So half of -10 is -5. Squared is 25. I know that the purpose of completing this square is to make this a trinomial that factors like this. So I like just writing that there. I know that's what it's going to come out to, some parentheses squared. That's the whole purpose, try to get this to be some parentheses squared. So the other day when I was teaching it, I kind of do it all in one step. I think, what's half of this middle term? That's what I know goes in here. Right? Half of my middle term goes here. And then I square that, -5, and it goes up here. So that's what I was doing the other day. It's kind of doing it all at once. But if you add 25 to the left, you have to add 25 to the right. Again, this factors as x minus 5 squared. You could check it if you wanted to multiply it out. And then -9 plus 25 is 16. So in order to solve this, we're going to solve by using square roots. Square root of x minus 5 squared, just they cancel out, we get x minus 5 on this side. Square root of 16, remember, is plus or minus 4. That's how you get your two solutions. You're going to solve this twice. X minus 5 could be positive 4. X minus 5 could be negative 4. So there's two solutions. You want to add 5 to both sides in both cases, but here we get 9, and here we get 1. Now, the thing is, if this turned out to be a whole number, two whole numbers, then this was factorable to begin with. So we could have factored it, turns out, we could have factored it. But if the test says solve this by completing the square, you're going to need to know how to solve by completing the square. Okay? Okay, so graphing quadratics. There's basically three forms of a quadratic equation for graphing. There's the standard form, the vertex form, and the intercept form. Which one is this? First one. That's standard form, right? So that's standard form. Ax squared plus bx plus c. Which form is this part B? Vertex form, right? And which one of these is intercept form? D. Right? So in other words, factored form, intercept form is the same thing as factored form. Okay, so we talked about this a little bit before when we talked about the summer packet, remember? Basically, these three forms have different purposes. Obviously, vertex form, the purpose is it gives you the vertex really easily. But a vertex is not enough to graph, right? Down here, part D is intercept form. It gives you the two x-intercepts pretty easily. But even two intercepts isn't enough to really graph the whole parabola. You really need both pieces of information. You need a vertex and you need two other points, right? So when you have vertex given to you in the equation, you have to work to get the intercepts. When you're given the intercepts, you have to work to get the vertex. I mean, there's no real easy get it all at once. You have to work for something, okay? Standard form, you really have to work for all of it. It's not the best form for graphing. Let's put it that way, right? Okay, so to get the vertex here, there is basically two ways of doing it. You may remember negative b over 2a, comma, blank, right? That's a way to get the vertex. So in this case, 4 is our b, so negative 4 over 2 times 1 is just negative 2. So negative 2 is your first coordinate of the vertex. How do we get the y? Steph? Plug in negative 2 for x. So you plug in negative 2, you get negative 2 squared is 4, minus 8, minus 5. So that's what, negative 9? Negative 9. So our vertex is going to be negative 2, negative 9. That's one way of doing it. It's actually not my favorite way of doing it. I think there's an easier way, personally. Since you have to find the intercepts anyhow, if it can be factored, I like to just do that first. So if it can't be factored, then negative b over 2a is your way to go, right? But if it can be factored, it's kind of nice to put it in factored form because it gives you more information. I got x and 5 and 1 and positive 5 and negative 1, and that's my factored form. So that gives me the intercepts. What are my intercepts going to be? So my recording stopped. How'd that happen? Oh, it's still going. Okay. Hello, it's still going. All right. So -5 and 1 would be our intercepts. So you're going to write that as -5, 0, and 1, 0. We get that from the factored form. So if you plot the two intercepts, instead of doing -b over 2a to get that x value for the vertex, I know the vertex has to be halfway between these 2 points. So I know that it's going to be on this -2 line, because that's exactly halfway between 1 and -5. So I could, by graphing my two intercepts, I can figure out that the x value is -2 without having to do the -b over 2a. Do you follow that? And then, my preferred method, I think, is easier. Plugging in the -2, to me, is easier here than with the x squared, right? If I plug in -2 here, I get -2 minus 1 is -3, and -2 plus 5 is +3, and then -3 times 3 is -9. So to me, it's easier plugging it into the factored form also, so if there is a way to factor, I would do that first. All right, how do you get the y-intercept? This is always, for all of math ever. To get the x-intercept, you do one thing, and to get the y-intercept, you do another thing. Victor. 0 for, so to get the y-intercept, you get to put in a 0 for x. To get the x-intercept, you put in a 0 for y. That's basically always. Okay, so to get the y-intercept, we're going to put in 0 for x. And again, to me, this is easier plugging into the factored form. Okay, so plug in 0 here. 0 minus 1 is -1. 0 plus 5 is 5. Multiply -1 times 5, and you get -5. So the y-intercept is at 0, -5. The vertex we said is at -2, -9. And this all makes sense. A little too pointy, but that's okay. Okay, so vertex form, you're going to use the equation to get the vertex. Remember, this is like a times x minus h squared plus k, where hk is your vertex. So there's that little trick about the opposite sign in the parentheses, right? So what would be the vertex for this problem? B. Would be the vertex, Caroline? Good. -2. Actually, k is also -2. So the opposite is only when it's in the parentheses. So this one kind of switches its sign. The x switches its sign. The k keeps the sign. So it's -2, -2 here is the vertex. All right. What did we say about finding the y-intercept? What do we do? Plug in 0 for x. So that should be pretty easy to do. Plug in 0 here. We get 2 times 0 plus 2 squared. So we got to do the squared first. 0 plus 2 is 2. Squared is 4. Times 2 is 8. Minus 2 is 6. So the y-intercept is going to be at 0, 6. The vertex is at -2, -2. And we need our intercepts. What did we say about finding the x-intercept? Well, we need to find the 2 points that actually go through this graph. So remember, we said to find the y-intercept, you plug in 0 for x, and to find the x-intercept, you plug in 0 for y. That's always going to be the case. Well, remember that the way this is written, g of x equals 2 times x plus 2 squared minus 2, where's the y? G of x is the y, right? That's like another way of thinking of it as y. So to find the x-intercept, you're going to plug in 0 right there. This is to find the x-intercept. I'm going to point down here, right? And then you solve this just like it was if I said solve this for x. What would you do to both sides? You got to isolate the x plus 2 squared. You got to isolate that. So what should we do to both sides? Subtract, add. We're going to add 2, right? Because this is minus 2, so we're going to add 2 to both sides. We get 2 equals 2 times x plus 2 squared. Now what do we do? Divide both sides by 2. We get 1 equals x plus 2 squared. Now what do we do? Square root both sides. We get x plus 2 on one side. What do we get on the left? Plus or minus 1. So again, we have to solve this twice. X plus 2 equals 1, and x plus 2 equals negative 1. Subtract 2 from both sides, you get negative 1 here and negative 3 here, and that's your x. So those are your x-intercepts. Negative 1, 0, and negative 3, 0. Negative 1, 0, negative 3, 0. Which makes sense because our vertex was at negative 2 something, right? Which is halfway between negative 1 and negative 3. So makes sense. Okay, I'm going to let you guys do these two as practice eventually, right? Because we've gone over all the skills. This is factored form. We pretty much did factored form because we factored this one, A, right? So that's the same process here. And this is standard form again, so it's going to be the same as A as well. Yeah, that can be factored. Okay?